For my test video, I was given to find the dimensions of a rectangle with a perimeter of 64 meters whose area is large as possible. In order to find this, I know that it's an optimization problem from the wording of as large as possible. So from that, I also can figure out that this is in fact asking me to maximize the area function, which in the case of a rectangle, where you'd have two sides that are equal to x and two sides that are equal to y, because a rectangle's sides are different, you'd get a formula for area equaling to a equals x times y, right? So from there, you find your constraints. So in this case, the constraint is the fact that the perimeter is supposed to be 64 meters. So the 64 meter perimeter must be equal to 2 of the x components plus 2 of the y components, which gives you 64 is equal to 2x plus 2y. From there, I solve for y, because you have to be able to plug something back in to your original function of the constraint in order to use this constraint to solve for your maximization. So by plugging it back in, you get a is equal to x, and then in parentheses 32 minus x, which then you distribute the x into. So you get a is equal to 32x minus x squared. Taking the first derivative of this, you get 32 minus 2x, of which then you set equal to 0, and you end up with an x value equaling the 16. So with an x value of 16, the next thing we have to do is determine if this is in fact a maximum value, in fact a local maximum as a critical point. So from there, we take the second derivative of a prime of a, which is equal to 2. So because a double prime is always negative, that means that 16 by the second derivative test would be a local maximum. From there, since we know that this is a local maximum, which is a point that will maximize the total area, we then plug the 16 back into the perimeter function, where we get 64 is equal to 2 times 16 plus 2y, where then we solve for y, where y is now equal to 16. With both x and y equaling to 16, your maximum area is 256 cubic meters squared, so square meters, I should say. And because of this, we also know that because y and x are in fact the same value, the rectangle that we are talking about is actually a square, where all sides are equal to the same value.